Hey everyone, welcome to today's video. Today we are going to talk about live data, but what we are going to do is we are going to create our own implementation of live data, and through that we'll try to understand how live data actually is lifecycle aware and how it helps us to manage our UI state with respect to the data state of the app, right? So to proceed forward, I have a sample project over here, and it's pretty basic right now. So what I've done is basically I have a main activity. I have created a view model. Inside the view model, I have taken a counter variable. I have added live data, which is mutable in nature, right? And now I've written a function which will run a counter. So inside that function, it will basically launch a view model scope, right? And inside that scope, it will basically run a while loop till the counter is less than 5, right? So every time the counter is less than 5, it will go inside the loop. It will increment the counter by 1, and then that live data, it will post the value inside the live data. The counter would be the value, right? So we would get the counter in the main activity, right? So we would get the live data updated, and then it would wait for 1 second. So basically this loop would increment the counter by 1, push the value to the live data, wait for 1 second, and do it all over again until and unless the counter is not equal to 5 or more than 5, right? So as long as it's less than 5, it will keep on running. So it'll go like 0, 1, 2, 3, 4, 5, right? So in the main activity, what I do is basically I create an instance of view model, right? Our main view model that we have. So I use the view model provider class. Now, one thing over here is that if you want to know in depth about the view model provider class, then I would add the description to my video where I have explained this in depth in the description. And I will also add a card to this video right about here in the top. So we use this view model provider class. We pass the owner to it. We get hold of the main view model, right? And so then after that, we get hold of the live data variable. We add a observe method to it. And then whenever this observe is invoked, then in that case, whatever value is returned over here, we set it to a live data, to a text view, right? So if we go inside this text view, we can see, so this is the main activity, right? So inside which I have two text views. One is called the live data text view. The other one is called my own live data text view, right? So inside the live data text view, it will just take it will initially show no data, and then as and when the live data updates, it would increment the counter 1, 2, 3, 4, 5 like that, right? So I will just run this project, right? So I have my screen over here. Yeah, you can see that it's increasing, right? 1, 2, 3, 4, 5, right? So this text is changing. The other text I have not done anything, so it's still showing no data, right? So this is the basic live data implementation. So now let's go ahead and implement our own live data class, right? So what I'll do is I'll create a new class over here. I'll do new Kotlin class, and then I'll name it as my live data, right? So here what I'll do is it will take a type generic, right? So T denotes generic over here. So if I click on this, you can see that it's a generic type, right? Because the live data can hold anything. It can be an integer, it can be a string, it can be any custom object, right? So that is why the T over here. Now we'll go ahead, and some variable needs to hold the data, right? So we'll create a private variable called data holder, right? So it will be also of type T but nullable, and the default value of it will be null, right? So now we have the data holder. Now what we need to do is we need to create a setter method and a getter method, right? Like in the view model, if you go, we are setting the data over here using this post value, right? So we'll create a fun post value, right? So here what we will do is we'll pass in a value of type T again, right? So internally what this will do is data holder is equal to value, right? So this will just set the value inside the data holder. So we have the setter. Now it's time for the getter, right? So fun get value, and this will just return the data holder, right? So the get value is also here. Now that we have the post value and the get value methods, so this class will just act as a data holder, right? So it just has a variable which holds the data, and then whenever you call get data, it would return it, right? But it is not reactive, so to say, right? So the publisher part of it, right? The live data works in a publisher subscriber pattern, right? Observer pattern. So basically the publisher part of it is kind of done because we are able to post the value, but there's no observer for it, right? So every time we need an updated value, we need to call the get value method. We won't be automatically notified about it, right? So let's go ahead and create a method called fun add observer, right? So in this observer, what we will have is we will have a method as an argument, right? So this will be a higher order function. So it will be like t generic is the argument type. It's nullable in nature, right? And the return type of this will be unit. So inside I need to give the name for an argument, observer, right? Observer of type t. Yes, correct. So now we have the method to add an observer, but we need to be able to hold the observer somewhere, right? And now one thing to think here is that one live data can have multiple observers, right? So it just won't be one. So we need to maintain an array list of observers, correct? So let's go ahead and place in an array list of observers over here. So what we will do is we'll create an array list, private val array list of observers, right? That will be of type array list of type. The only argument will be like the observer which we have over here, right? So we can just copy this part and we can paste it over here. We'll remove the bracket, right? And then we need to initialize it. So it will be an empty array list to start off with, right? And every time you call this add observer method, then what will happen is basically it will call array list of observers dot add, and inside it will just place the observer, right? So we have the observers and we have an array list where we can add them, right? And so in order to notify them, what will happen is every time you call this post value method, right, then we will invoke those observers. So it's very similar to say a method called like set on click listener, right? So you have a button, you add a listener to it, and then every time the button is clicked, you get the callback that the button was clicked, right? So similarly here, every time the value is set, we will send a callback, correct? So here we will add that array list. Those will get hold of all of the observers. So we'll run a for each loop inside, and then what we will do is basically we'll call it.invoke, right? So we'll call whoever is listening to it, we'll call the invoke method on them, and then we will pass the data holder, right? So that will be the value which will be passed to them, correct? So this is a very basic implementation of it, right? So let's see what are how it would work if we were to integrate it in our view model. So we have the normal live data over here. Let's create our own, right? So my data provider, right? Let's name it, and it will be of type my live data, right? And here also it will be my live data, correct? So it's very similar, right? Now what we'll do is every time here the live data was updated, we'll also update our data, our live data, right? So we'll do my data provider dot post value, and we'll pass in counter, right? Similar to what we did for the live data. Now we'll go into the main activity. Here, like we have observed the live data, actual live data, we'll try to observe ours, right? So main view model dot my data provider dot observe add observer, right? So this is basically a lambda function which is created, right? So we have the integer over here as a param. So what we will do is we'll call the other text view, right? So here we have this my own live data text view, right? So this we will call over here dot text, and we will pass in it.toString, correct? So now it has like it's going to behave the same as the live data, right? So we'll try to run this, and this should also update as and when the live data updates, right? So this first text view should also update as and the second text view should also update, right? So you can see this is also updating, this is also updating right now, right? But the thing we have missed over here is that this is not lifecycle aware. So what if I rotate the screen, right? So in that case, you see that the actual live data was able to retain the value, but the other one, the one we created, was not able to retain the value, and it went back to the default value, which is no data. Similarly, if I rotate it again, it still holds the value, the actual live data, right? But ours does not. So what the next step we need to do is convert this and maintain the state over here, the lifecycle state over here, right? So now we'll try to modify this class and add some methods or some handlers for the lifecycle state, right? So to begin with, we'll create our own lifecycle observer. Okay, let's create a private inner class, right? So we'll call it lifecycle observer wrapper, right? So that will extend the lifecycle observer, correct? Since we need to be able to watch it, right? So we'll need to have the callbacks for the life cycles. So we need to extend the lifecycle observer, right? So now in the parameters, similar to what live data, the actual live data is taking, we'll try to make it similar to that, right? So the first parameter is a lifecycle owner, right? And the second parameter is the observer part. So we already have the observer part. Let's go ahead and add a lifecycle owner to it, right? So we'll add a private val lifecycle owner, correct? That's the first. And the second parameter would be the same observer that we already have, right? So we'll copy it from here, we'll paste it over here, right? So now here, if we come down, what we need to do is to handle the various lifecycle states, we will just here take care of the on start, the on resume, and the on destroy, right? So we need to be able to send the values again as soon as on start is called, as soon as on resume is called, the latest values will be pushed, and when on destroy is called, at that point in time we will remove any kind of observers, right? So for now, let's create three methods: fun, do, on, start, right? So this should do something when on start is called. Fun, do, on, resume. So this should do something when on resume is called, and fun, do, on destroy, right? So this should do something when on destroy is called for the life cycle, right? So here, in order for these methods to be called, we'll add the annotations, right, on life cycle event, right? And we will pass in over here lifecycle dot event dot on start, because this is supposed to be called when the on start event happens, right? So we'll copy this, we'll paste it over here, and this we will edit. We need to be calling this when on resume is called, right? And this one we need to be calling when on destroy is called, right? So we'll pass in destroy. Now these methods will be called as and when the various lifecycle methods are called, right? So now we have a lifecycle observer wrapper, but we are still like missing something, right? We need to be able to modify this and make our list of observers also be able to handle that state, correct? So what we will do is, now that we have these three methods, we need to be doing something when all of these are called, right? So in that case, what we will do is we'll add a few methods over here. We'll call it fun notify value changed, right? So notify value changed or update value, right? So we'll call this, and here what will happen is basically we need to be able to get hold of a lifecycle observer, right? And then we need to be able to pass that value to it, right? We need to be able to invoke the observer, right? So we'll take an observer over here and we'll call observer dot invoke, and we'll pass in whatever the current value of data holder is, right? So whenever update value is called, the observer would be taken as an argument, and then we would just simply pass the value to the observer, right? Now this update value needs to be called every time on start is called, right? So we'll pass in update value over here and we'll pass in the observer. Okay, I need to add private value to this, right? Okay, so we'll be able to access the observer over here, and similarly we need to also update the value in on resume, right? So the latest values. So now whenever on start and on resume is called, the latest values will be passed to via this update value method to whoever is listening, whoever the observer is, right? So similarly for the on destroy, we need to do something, right? So in on destroy, we need to remove the observer altogether, correct? But before that, let's go ahead and change our add observer method in order to understand it better, right? So in the add observer, we need to be able to create our lifecycle observer wrapper, right? So that we can properly like do something on the state changes. So we'll just add one the missing argument over here, right, which is the lifecycle owner. So we'll add lifecycle owner, comma, right? Then we'll create an instance of the lifecycle observer wrapper, right? So what we will do is val owner is equal to lifecycle observer wrapper, right? And here we will pass in the two arguments, which are lifecycle owner and observer, correct? So we now have an instance of the owner. Now what we need to do is basically add some method, add an observer to this lifecycle, right? So what we will do is okay, before that we need to just remove these and make this non-private so that we can access it from outside. So we'll do owner dot lifecycle owner dot will get hold of the lifecycle dot add observer, right? So that we can observe the state changes of it, and there we will pass in an observer which is our owner, right here. So we will pass this. Now we are basically accepting all of the changes to this lifecycle state and observing them, and these methods will be called accordingly, right? Now that I have added handled the state for these two, let's go ahead and fix our observer method, right? So the observer right now only takes one parameter, which is the lambda method, right? So what we will do is basically pass in a lifecycle over here, the lifecycle owner, right? So we'll add a lifecycle owner over here. Inside, once we've added the lifecycle owner, we need to be able to create our lifecycle observer wrapper, and then once the wrapper is created, we will try to add an observer to it, right? So we'll do lifecycle owner wrapper and we'll pass in lifecycle and owner, right? Okay, we'll fix the name for this first, which is the I is capital. We'll fix this, right? Dot apply, right? So here we'll get an instance of it, and what we will do is lifecycle owner dot lifecycle will get hold of the lifecycle, and then we'll do add observer. Here we will pass in our wrapper, which is basically this, right? So basically whenever we get hold of this lifecycle, we add an observer to it, which is basically our wrapper, correct? So this has been added, but somehow we need to store this somewhere, right? So that we can call this invoke method. This array list of observers will basically call any item inside it, right? So even if the on destroy state is called, we should be able to remove all of that, right? So what we will do is basically we will modify this into a hash map, right? Hash map will change the type into a hash map. The first argument will be the same, right, as that of an observer, and then the second argument, the value part of it, right, the key is the same, the value part of it is basically our wrapper lifecycle wrapper, right? So this we will initialize it as an empty hash map. We'll change the name to hash map of observers, right? So now that we have the hash map, what we will do is we'll comment out this code for now, right? And here in the add observer, we will add this instance of it into the hash map for further tracking, right? So what we will do is hash map of observers. The key will be the observer, right? So and the value would be this, correct? So this has been added, correct? So the lifecycle observer wrapper is added to the lifecycle as well as the observer of hash maps, and then we will just remove this, right? So now I think our add observer method looks good. So if this is a little complicated, I think this is fine because it's in the middle of it. At the end, I think it will be all clear to us, right? So now the add observer method is working properly. The update value is proper. We just need to be able to handle the on destroy state, which we will add a remove observer, right? So we'll add fun remove observer. So here what we will do is we'll take hold of an observer instance, right? So and then we'll get hold of the wrapper from the hash map. So hash map of observers observer, right, dot run, right? So we'll only run if an value is found, right? So now we have the wrapper, so we'll do lifecycle owner. So this dot okay, so the lifecycle owner is not available because the fields are private, so we'll try to make them as not private, right? So here also I think we need to add this keyword, right? So same as here, this dot lifecycle owner dot lifecycle dot remove observer, and we would just remove our implementation of it, right? So when you're adding an observer, then we add it to the life cycle, right? We add the observer to the life cycle. When this remove is called, we get hold of the proper instance and then we are removing it, right? So this remove observer would remove it from here, right? And in that case, it would also remove it. It should be able to remove it from the hash map itself, correct? So we have a remove observer method ready. We'll copy it, and in on destroy, our observer should be removed, right, from the lifecycle chain. So what we will do is we'll pass the observer over here, and our methods are ready, right? So our observer wrapper is ready. Now the only thing left is whenever you're doing a post value, then in that case we should be able to get hold of the proper instances which is still active, the observers which is still active, right, and only notify those, correct? So we'll remove it from here, and what we will do is basically get hold of a hash map of observers, right? We'll run a for dot values, right? We get hold of all the lifecycle observer wrappers that we had, and then we will do a for each loop, right? So in that case, we'll loop through all of the lifecycle observer wrappers. What we will do is we'll run an if statement if it dot lifecycle owner dot lifecycle dot current state dot is at least, right? If it is at least lifecycle dot state dot started, right? So if the lifecycle owners for this particular instant, if the lifecycle owner's lifecycle current state is at least started, then in that case we would need to go ahead and invoke the method, right? So we would do it dot lifecycle owner dot it dot observer dot invoke, right? So we'll pass in whatever the value of data holder is, correct? So we first check the life cycle if it is started, then in that case we go ahead and we call our observer and invoke the value, right? So I think this looks good, right? So let's go ahead and make the changes for our implementation. So the only change that we would notice is the view model would be the same, but the main activity, we just need to modify the add observer method, right? So I'll remove this. I'll call add observer again. So here I understand I need to pass the same arguments as that of the live data, right? So lifecycle owner and an observer. So lifecycle owner I will pass in as the activity, which is this, and then the observer I will do this, and I'll get the integer value, right? A nullable integer. So let's just do something. We'll just check it dot, right? So this will remove all the null values and we'll only get the non-null values. So what we will do is my own live data text we will call. We'll do text is equal to it.toString, right? So instead of it, I think we need to pass in this over here, because it would be pointing it to the nullable integer. It would also be fine, but I'll just prefer to use this side over here. So I'll go ahead and run this. So if I do, once this runs, let's do this. See, our lifecycle events are being handled, and it's being like not the lifecycle events. We don't know that yet. We'll only get to know once we rotate the screen. But it worked fine as that of the live data, right? So it updated the values. Now the moment of truth, we'll just rotate the screen, right? So once we rotate the screen, we still see that the 5 is present. Previously, we were seeing no data available, right? So inside of the text view. So here again, if we rotate it one more time, we still see that the data is available, right? So it behaves exactly the same as that of the normal live data class, right? So I think we were able to achieve our implementation, a very basic function of it. There are lots of other things which live data does. It properly clears the instances and everything. Maybe we missed out on some things, but just for a fair brief understanding, right? So what I'll do is right now I'll just summarize once very shortly, so that it's just more clear, right? So what we did is we created a class. We took the type as a T, which is generic, right? We created a member which would hold the generic type T. Initially it was null, right? And then we created a hash map of observers, right? So the hash map would basically have a key value pair. The key would be the observer. So the observer would be a method. So this method is basically this part, right? So this part is what we are passing. The method as an argument we are taking over here, right? So that is the key of our hash map. The value would be a custom class that we made, Lifecycle Observer wrapper. So inside this, if we go, so this is the custom class that we made. So it extends the Lifecycle Observer, right? So it's just a wrapper around the Lifecycle Observer. So what it does is it takes hold of a lifecycle owner as the first argument and the observer as the second argument, right? And then it defines three methods. So three methods are to react to the three states whenever they come. So the first state is on start, the second state is on resume, and the third state is on destroy, right? So whenever on start is called, it would try to update the value. Whenever on resume is called, we'll change the method name of this, right? Just to fix this. Yeah. So whenever on resume is called, it will try to update the latest value of it using this update value function. Whenever on destroy is called, it will try to not notice any more changes to the life cycle, right? So what will happen is basically here, if we check the update value method, which is basically being called over here, the update value method takes an observer. It calls the invoke function of the observer and passes in whatever the value of the data holder is currently, right? And similarly, the RemoveObserver method, so that method gets hold of the observer from using the observer being used as the key over here, gets hold of the lifecycle observer wrapper, right, using the observer from the hash map. So passes the key to the hash map, and then it gets hold of the value from them. And so there it calls the lifecycle from that lifecycle owner, and it removes the observer wrapper. It gets hold of the lifecycle, right, and then it removes the observer wrapper that we had attached to it, correct? So that is what is being done over here. And then in the we have two methods called post value and get value. So the post value is very similar to the live data's method called post value, wherein whenever you want to update the value of the live data, you call this, you pass in the value which is of type T, which is same as that of when you are initializing the live data, right? So there what we do is we set the value to the data holder, and then we get hold of all the values from the hash map, which are basically all the observer wrappers. We run a loop through them. We check whether the life cycle present inside this observer wrapper is at least in the started state, right? It's not in the destroyed state, right? So if it is in the started state, then in that case we call it.observer. So from the same hash map, we get hold of just the it, right, from the wrapper, and then the observer, from the wrapper, and then we call the invoke method on the observer, so that anyone who is listening using that observer can be updated with the proper value of it, right? And whenever you want to forcefully get a value, you would call the get value method just to get the latest value of the data holder, right? So those are the two values. The last those are the two methods, right, for the get value and the post value. The last thing that we added over here is the add observer method. So this add observer method is used to observe the changes, right, anywhere, which is the most important method I feel over here. So there we pass in a lifecycle owner and an observer. So the observer is the method which is to be called when there is a change, and the lifecycle owner is so that we can track whether the state of it changed or not, right? So there we create a wrapper from these two instances, right? So after we get hold of a wrapper instance, our custom wrapper instance, right? So here, once we get hold of this, then in that case, we get hold of the lifecycle owner. We check the lifecycle from there, and then we just add an observer to it, which is basically our custom lifecycle observer, right? So we just add this observer over here, and then we also add the same observer to the hash map, which we just made over here. And for the key, we pass in the observer, right? So inside the hash map for this key, this particular wrapper would be stored, right? So this is stored so that when we are removing it, we can get hold of it from the hash map, right? So like we check our whenever, even though we rotate it, it works fine, right? So the data state is preserved even though the life cycle changes. So basically our custom implementation of the life cycle is there, and we were able to handle it properly and also update the UI properly so that the current data state and the current UI state are in the same level, right? So what I'll do is basically I'll upload the code for this into GitHub. I'll provide the link of it in the description, right? So if anyone wants to refer, I think that will be helpful for them. So I hope you enjoyed this video and maybe I was able to share something with you. Do check out the other videos I have on my channel if you want to get into the depth of a few things that we do in our daily lives as a software developer and as an Android developer, right? So yeah, I hope you enjoyed this. Thank you.